Question 3. In the xy coordinate plane, is point P equidistant from points -5, -5, and 3, -5? We are given two statements. The y coordinate of point P is -5, and the second statement says that the x coordinate of point P is -1. So, what does the question really mean? To find whether point P is equidistant or at the same distance from points -5, -5, and 3, -5, actually means that we need to know exactly where the point is located horizontally. Why? Because these 2 points have exactly the same vertical position. So the fact that they are symmetrical in their vertical position means that the vertical position of P doesn't determine at all whether point P is equidistant from the 2 points. Only the horizontal position will make that clear. We can notice this if we actually draw the approximate locations of points, the points in the question. Okay, if we draw part of the third and fourth quadrants of a plane, we can notice that if -5 horizontally and vertically are here and +3 is here, then this is the approximate location of the first point, while this is the approximate location of the second point. You can notice that being them at the same vertical position, any point on the plane, let's say this point, we don't mind the horizontal or the vertical position of a point like this, Q, because what will determine its distance to the 2 points being equal or not is whether the horizontal position of the point, you know, this distance here versus this distance here is the same or not. That's what will determine whether the point is at the same distance. So, because of this, we can be sure that statement 1 alone is not sufficient, because statement 1 provides us exactly with the vertical position of the point. And being the vertical position of the point P exactly the same position of the 2 points, that puts point P alongside the line containing the 2 given points. It could be anywhere on this virtual horizontal line. Obviously, there are infinite positions for which point P can be actually not at the same distance, and there is only one position at which point P would be equidistant from the 2 points. Actually, the position where the horizontal coordinate of P is exactly at the same distance from -5 and +3, which, by the way, since what separates the horizontal coordinates of the points is 8 units, it would have another point that is exactly at 4 units away from each point horizontally. And that corresponds to -1, right? Between -1 and -5, 4 units of distance. Between -1 and +3, also 4 units of distance. So only in this position would point P be equidistant. Here, you would have a yes for an answer, but in any other position, you would have a no for an answer. So statement 1 is not sufficient. What about statement 2? Statement 2 actually gives us the only coordinate of the point that is relevant to determine whether it is equidistant or not. Having that point P has a coordinate of -1 horizontally speaking, places the point on a position that could be alongside this virtual vertical line, which exactly crosses the x-axis on coordinate -1. That is, the equation of this line would be x equals -1. point P might be anywhere over that line. So, for example, if P is here, would it be at the same distance from the 2 points? Or if it's here, it would be at the same distance or not? Well, we can determine that this has to be a yes in all cases, because the 2 points given here can be considered the endpoints of a line segment that is completely horizontal. And the virtual vertical line x equals -1 can be considered its perpendicular bisector because it is completely vertical. It crosses a completely horizontal segment, so it's perpendicular to it, and it crosses the segment exactly in its midpoint, meaning that any point on this perpendicular bisector must possess the same distance, right, to the endpoints of the segment this virtual line bisects. This distance here is the same as this here. And from another possible position at a higher vertical position, this distance here would have to be also the same. So you can see that in all cases, points over this virtual vertical line would be at the same distance of the 2 points given in the question, yielding a unique answer that is always affirmative, meaning statement 2 alone is sufficient. The correct answer would be option B. Statement 1 alone not sufficient, statement 2 alone is sufficient.